Alright, in this video we're going to talk about Unit 3, Objective 7, partial fraction decomposition. Now this sounds a lot scarier than it actually is. So let's just jump in, look at an example real quick. So we have the antiderivative of x minus 3 over 2x squared minus 7x plus 3. So our first thought is, this is a quotient. We don't have a quotient rule. Let's try u. So our first thought would be u is our denominator. So 2x squared minus 7x plus 3. du is going to be 4x minus 7 dx. Well, that's a problem. I don't have a 4x minus 7 dx. I can't mess around with this to get a 4x minus 7 dx. We're stuck. There's nothing else we can do. We're done. Except we can think about partial fraction decomposition. So in order to kind of explain how we use partial fractions, we're going to look at an example from Algebra 2, something that's related. If we have the fraction 3 over x plus 1, and we're adding that to the fraction 4 over x minus 2, we would want to get a common denominator. So we would think about our common denominator being x plus 1 times x minus 2. So we would want to say 3 times x minus 2 over x plus 1 times x minus 2 plus 4 times x plus 1 over x plus 1 times x minus 2. And then we would combine it. You probably wouldn't write this step, but I'm going to write this step because we're going to use it for our partial fractions. So we're going to end up with this. 3 times x minus 2 plus 4 times x plus 1 over x plus 1 times x minus 2. And then if we were to simplify it, we're going to end up at 7x minus 2 in our numerator and x squared minus x minus 2 in our denominator. Oops. So what we're doing here is we are combining like terms to get one thing. Now, if I were to ask you to take the antiderivative of this, you wouldn't be able to. You'd hit the same wall that we just hit a second ago. But if I were to ask you to take the antiderivative of this, we can go at that problem. We can take a shot at it. We can figure out what the answer to that is. So that's what we're going to do with partial fractions. We're going to start with something like this, and we are going to basically uncombine like terms. So we're going to split this problem up and try to end up here so we can take an antiderivative. So let's take a look at what that looks like. So we're going to go back to that first problem. If you look at the steps that we took a second ago, we wanted to start by factoring our denominator. So whenever you're looking at a quotient and your u substitution is not going to work, factor your denominator. So if you factor the bottom, you get 2x minus 1, x minus 3. That by itself does not fix the problem. We still can't do anything with that. So what we're going to do next is we're going to think about this. I know that some number a over 2x minus 1 plus some number b over x minus 3 is going to equal this. And if it was going to equal that, we'd have to say, well, a times x minus 3 plus b times 2x minus 1 all over 2x minus 1, x minus 3. Right? We'd have this thing working out, and we know that this is going to be equal to x minus 13 over 2x minus 1, x minus 3. The trick is we need to find a and b. We need to find the a and b such that a times x minus 3 plus b times 2x minus 1 is going to simplify to x minus 13. So how we're going to do that is we're going to focus just on our numerators, right? We know the denominators are the same, but we're going to focus just here to figure out what a and b are. So we're going to look at just a times x minus 3 plus b times 2x minus 1, and knowing that that has to equal x minus 13. Sorry about that. So we need to figure out A and B, and here's the problem. We have A, we have B, we have X. We need to get rid of two of them. So the easiest way to get rid of two of those to solve for the third is just pick a value of X that's going to help us get rid of A or B. So if X equals 3, then we know 0A plus 5B is going to be equal to negative 10. So put 3 in here. 3 minus 3 is 0. 0A, that's basically gone. 3 times 2 is 6. Minus 1 is 5B. 3 minus 13 is going to be negative 10. Well, if we solve that, we know B has to equal negative 2. So we're going to pick an X that's going to help us get rid of A. Then we're going to say, well, if X equals 1/2, we know that negative 5/2 A plus, well, if we make this 1/2, 2 times 1/2 is 1, minus 1 is 0, so B is gone, is going to have to equal negative 25/2. And if you solve that, we're going to get that A is going to be equal to 5. We know now what A and B are. 5 and negative 2 are going to make this turn into this. So we can rewrite our problem up here now as the antiderivative of 5 over 2x minus 1 plus, and not really plus, but should be minus because we have negative 2, over x minus 3. And that's the antiderivative now that we want to take into account. Now looking at it, we have two quotients. Quotients really aren't good. We can't use a u on one of them because it's not going to make the other one true. But what we can do is, since we have a plus sign, we can rewrite this as two separate problems. So I'm going to pull the 5 out front. Put a little squiggly line down here. 5 out front, and then we're going to have 1 over 2x minus 1 dx. Take the negative 2, pull it out front. And then we have 1 over x minus 3 dx. And now we have two pretty straightforward, easy problems. So if we look at this one here, we can say u equals 2x minus 1, because that's our denominator. Du would be 2 dx. I don't have a 2 dx, so we know 1/2 du equals dx. So I can rewrite this first one, take your 1/2, put it out front. We're going to get a 5/2, because we have that 5, times the antiderivative of 1 over u du. Same idea with this one. U is going to be x minus 3. Du is going to be dx. Well, I have a dx, so that's a nice, easy transition. So minus 2 from the minus 2. Antiderivative, 1 over u du. Antiderivative of 1 over u is the natural log of the absolute value of u minus 2 times the natural log of the absolute value of u plus c. And then we just have to put the u's back in. Now keep in mind we had different u's. So that's first one is 5/2 natural log of the absolute value of 2x minus 1 minus 2 natural log of the absolute value of x minus 3, and then plus c. So that's a whole lot of work. But as long as you go slow and figure out A and B, it's not going to be a huge deal. So we'll call it quits on this video, and we'll see you in the next one.